differently. Isn't it curious? So, I lived in the 4th century and I noted that the object falls of speed proportionate to its weight. So, the heavier object is, the faster it will fall. And in the 17th century, by my experiment, by dropping iron balls of unequal weight, by the leaning tower of Pisa, I see that the rate of fall caused by gravity is the same for all objects. So, what is the solution of this problem?
So, let's analyze this experiment. Galileo wrote the ball down. Well, it wasn't using seconds per se, he did use poles to take time. He found it no matter what the slope for what ball used, the distance traveled was always proportional to the square the time. So if t equals 1, then the objects will have moved some within 3, it was 9 at 4, guess at 16. This doesn't necessarily mean that x is going to equal square at the time, just that it's going to equal some constant multiple the square of the time. That's to say that x is proportional to the square t. So that means that you could take a constant and associate with the Earth's gravitation pull, some number that you could multiply by time squared to get the distance that the object falls. If you consider the ball on a ramp, gravity, the Earth is trying to pull up straight down that way to the ball. The rate, meanwhile, is pushing up with a force that's perpendicular to the area. That's called normal force. Friction tries to hold the ball in place while a component of the Earth for the ball pulls, parallel to the ramp and down the ramp. The other component of the ball's weight is perpendicular to the ramp, is equal and opposite the normal. Using our handy-dandy dream functions, we find that the harder the force of the Earth on the ball is pulling down as a ramp is equal to mg sine theta. So he had managed to daily gravity by the sine at the angle.
So, finally Galileo was right. Thank you.